So here's that video I promised you. First thing we have is momentum. Now momentum is when an object is moving. It has within it a quality that wants to keep it moving, and we call that momentum. It depends on two things. It depends on the mass of the car. More massive, more momentum it'll have, and it'll depend on how fast the car's going. So if the car's going really quick, it'll have more momentum if it was going really slow. So a nice easy equation, this one. The momentum, and I just write it as MMT, is equal to M times V. Now the unit is pretty easy. Mass is measured in kilograms, velocity is measured in meters per second, so the unit for momentum is kilograms meters per second. It goes into a triangle nicely, so we can have mv and the momentum at the top, and I'd like you to try and rearrange that, put them over on the side here, v equals, and then can you have a go at one? If the momentum of this car was 2,000 kilograms meters per second and had a mass of 400 kilograms, could you find the velocity for me? And here we have some more questions, so hit the pause button, copy these into your book and have a go at them. Next equation. When an object's already moving along, it has momentum, as we've already seen. So here's my car. Now, if my car changes its momentum, i.e. hits a wall or puts on the brakes, then there's going to be a force generated at the point where it hits. Now, to calculate this force, we look for the change in momentum. So the equation for this one is change in momentum divided by the time. Because it's obvious, the harder and the faster you hit something, the more force that's going to be generated. This is why you hit things with a hammer, why in karate and martial arts you hit as fast as you can and then you pull back to reduce the time that you're hitting for. Now manufacturers have used this because they want to increase for as long as possible this time for decelerating, for changing your momentum. So they've added 3 features to all their cars. The first one is, and I'm just loading it up now, they've added in crumple zones. You did crumple zones in year 7. The idea that the front and the back of a car are losable, excuse me, and that as you hit the wall, backwards in this case, the back of the car crumples and you decelerate slowly. This will make the time increase, keeping the force on your body low. The other one that they've added is they've added airbags. Again, same idea, they decelerate you. You increase the time that it takes to slow down, and hence the force on your body stays slow. And the final one, introduced in the 70s, is the seat belt, which has probably saved more lives than any other feature in a car. So all 3 of these, and again I would write these in your book, all 3 are designed to increase the time, which in this equation will decrease the force. It goes into a triangle nicely again, so we can have, this time we have change in momentum. Now we usually call it delta momentum. Triangle means delta, it means a change, and Ft. And again, have a go, rearrange to make the momentum the subject and T the subject. And that is the lesson that you missed the other day. To all their cars.